Hello everyone, welcome to another video from Advanced Math Tutors. Today, in our series in Calculus 2, I wanted to bring you these types of questions. I see a lot of confusion about these types of questions, and I think the confusion comes from people don't know what to do when they see this x in the bounds of integration. And so I wanted to make a video clearing this up. So let's first review the fundamental theorem of calculus. It has two parts. The first part is the derivative of the integral of some function is equal to the function itself. And the second part is the integral from a to b of some function is equal to capital F of b minus capital F of a, where capital F is the integral of little f. And so let's see if we can use this to figure out what this problem is. Can we simplify this? Well, the derivative stays the same, but now let's apply the second fundamental theorem of calculus. This is equal to, and I'm going to write it like this, capital F of x minus capital F of 0. And now let's remind ourselves of what capital F of x is. Capital F of x is equal to the integral of little f of x dx. And little f of x is this t squared, or little f of t is equal to t squared. And so to get little f of x, well, we had to make a substitution. We're going to substitute t for x. So t is going to equal x. And now if we differentiate this equation implicitly, we get that dt must be equal to dx. And so now let's substitute those back in. T is equal to x, so that would go into there, and then dt is equal to dx, so we would substitute that one in for dt. Alright, and now when we do this, this is equal to the integral of x squared dx. Alright, and now let's deal with this f of 0, capital F of 0. Well, we do something very similar, but instead of replacing t with x, we're going to replace t with 0. So now t is equal to 0, and implicitly dt must be equal to 0 dx. Right, so now capital F of 0 is equal to the integral of 0 squared times 0 dx. And now this is 0 because we can pull out the constant 0. All of this becomes 0. And in general, if you encounter one of these problems and you see a constant in one of the bounds, you can just ignore it. So if you see like this capital F of x, capital F of 0 here, you can just automatically equate that to 0. And we're only left with this integral. So now we can apply the first fundamental theorem of calculus. Remember that derivative operator is still there, of the integral of x squared dx, which by the first fundamental theorem of calculus, this is equal to x squared. And that's our answer to the first problem. And it makes sense because we have a derivative of the integral of a function. And now it looks like what we did is we just substituted in x for t. And if you have a problem where the bound of integration is just x, you can absolutely do that. But if you have a problem like this next problem, where the bound of integration is a function of x, it becomes a little bit more complicated. So this is equal to, the derivative stays the same, of now, when we apply the second fundamental theorem of calculus, we get f of x squared this time, since that's the upper bound of integration. And now we subtract away capital F of 0, but remember what I said, we can automatically equate this second integral to 0 because this is a constant. This 0 here is a constant. And so we only have to worry about one integral. We now have, in our substitution, we now have t is equal to x squared this time, not just x. But watch what happens when we implicitly differentiate. We have dt is now equal to 2x dx. And like before, we're going to substitute in t for x squared, and then dt becomes this 2x dx. So let's rewrite this. The derivative stays the same of the integral of, here we have x squared, but it's squared because if we're substituting in x squared for t, in our function we have t squared, so this would become x squared quantity squared. So that's what comes down. And then we multiply again by 2x dx. All right, and now let's just simplify this. The derivative stays the same of the integral of 2x to the 5th dx. And by the first part of the fundamental theorem of calculus, this is 2x to the 5th. And that's our answer. All right, and this is how you would approach these types of problems where you have some function of x in the bounds of integration. So I hope this cleared up the confusion. Leave a like if it did, and don't forget to subscribe.